Hi, I'm Router Bob. Welcome to Sabre Nation University. In this lesson, I want to explore using Fusion 360 to create a part and to toolpath it. Then I'm going to show you how to output the G-code for your ShopSabre CNC router. Fusion 360 is a product of Autodesk. In case you're not familiar with that company, they were the originators of AutoCAD, one of the very first computer-aided design programs available for the PC. It even predates Windows. I started using AutoCAD at version 2, which was the mid-1980s. Back then, if you wanted to draw a line, you simply type line into the command line. All the commands were handled that way. The next great advancement was the addition of what are called hotkeys. So you simply type the letter L to draw a line. Fusion 360 is an unbelievably powerful product. It has CAD, it has solid modeling, it has parametrics, I think, that rival SolidWorks. It has excellent CAM functions and toolpathing. If there's one fault in the program, it is that it can do so much, it's hard to get a handle on it. But you know, the best part is they have a personal license that can be used non-commercially for free. That's the version I'm using in this lesson. Even if you use Fusion 360 commercially, the subscription rates are very reasonable. This is what Fusion 360 looks like when you first open it, and this is pretty much a default setting. Now, what's interesting is whether you run the Mac version or the Windows version, it's pretty much the same here. So that's really handy, and it's somewhat unusual. Now, here's how it's organized. This big area here where you see this grid turned on is actually considered to be the canvas. That's where we do drawing. That's where we create parts, and there's different views of it. There's a front view. You'll see all your views here, and to get back to the 3D view, you clip it like that, and we'll be using that as we do our practice. And then up here you have different icons and different groups, and then you have workspaces. So these are the workspaces. There's a design workspace, a generative design, render, animation, simulation, and a manufacturer workspace. The two we're going to be using are the design workspace, because that's where we create the part, and the manufacturer workspace is because that's what allows us to actually do the toolpathing that we'll need to run the part on our ShopSabre CNC machine. Now, another area that's up here, if you look at this, this is the data panel. This is where you keep things organized, and you keep files organized. You can do it by projects and whatever you want. I usually keep mine closed because I want to save the space. Then you don't actually have to be connected to the internet all the time to use Fusion 360. If you do this, go to job status, it lets you disconnect from the internet. Now, they recommend that you connect every week or two, all right? And then one other thing, preferences are here. Under your username, preferences, that's where you get to those. And there's times when we change those. All right, so that kind of gives us an overview of what Fusion 360 is going to look like when you open it up. Fusion 360 requires that we make a part by first creating one or more sketches. These form bodies, bodies then become components, and they can be combined into assemblies, all in the same drawing. While there are a number of ways to create parts in Fusion 360, I want to keep it as simple as possible. In fact, I draw the sketches similar to how I might draw them in VCarve Pro. We're going to make a standard right end panel that you might find in a base cabinet. I chose this part because it's almost universal, and it's also a great part to demonstrate toolpathing. One of the things that I personally found most difficult when starting Fusion 360 was understanding the sketching process, because some of the advanced parametric functions in the software were added into sketching that caused some unexpected outcomes. Eventually, I figured out an easier way to draw in Fusion 360, and I'll share that with you in this lesson. This is really a simple base cabinet end panel. How would you do in VCarve Pro? Well, I'd probably start out with a rectangle. So let's create a sketch, okay? Now, the first thing you do is you select the work plane. Now, that can be changed later, but you might as well select the same one the machine table rests on, so that looks pretty good. Okay, and then I'm gonna come up here, and I'm going to select a rectangle. Well, what size is it going to be? Let's make it 34.5. We'll tab over here by 23 and hit OK. And then we'll fit this on there. Whenever you see this faint color here, that means that's a closed shape. Now, you'll see some other things on there also. One of them is these things. These are called constraints, and that's what these are up here. And this is a rectangle, so that's what those constraints are. They're showing that those are horizontal and vertical. And I don't really need them. So I'll turn them off. They're there. They're just not being viewed. And then when you see these dimensions, if you double click them, you can override those. So that's how you change dimensions. So, so that panel is defined. When you see the lines being black, that means that's a closed shape, and then that's defined. Now, some of that doesn't make as much difference because remember, our goal is to make a panel. We're not trying to make an assembly or anything parametric. We're just trying to make a part. All right, so what else would I do? Well, I need a toe kick down here. I don't really have to create it in this drawing, but I just put the geometry there. So I'll select that. And once again, stretch it out, 3, hit the tab button, 4, hit that, that's there. And so that's all I'm gonna put on this sketch. I hit Finish Sketch. There's what it looks like. Now, to turn that into a model, if you go up here to Modify, you see Press Pull. Okay, I select that surface and you see that arrow. Now, because I didn't select this, you see, that toe kick's cut out of there. So I didn't really have to do very much, just make sure the shape's in there. And then how thick do I want that to be? 0.75. Okay, so that created a solid part. So that's the end panel. It's the right thickness. Now there's some things happened. It created this body over here. That's what you're seeing. And then it turned the sketch off. So the sketch is still there. It just turned it off. So when it created the body, it turned the sketch off. So that's basically our first step in creating a solid. Well, our cabinet part needs joinery. So think about, how would I do that in VCarve Pro? Well, I'd probably just draw some rectangles where the joints are and get them positioned, and then they would get toolpath. Well, let's approach that the same way. So let's create a sketch that has the joints on it. So we start by create sketch, and we'll pick that surface and we'll bring it out a little bit. I have better luck drawing out here in the canvas than moving it over. So let's do this. Let's create a little rectangle. 0.753. Okay, and you see it's got the dimensions and the constraints showing. We'll hide those. I'll look at another command here. I'm going to select that. I'm going to go to Modify, Move Copy. Okay. Now, when you see these little arrows, that lets you, that's a free move or free form. Well, that's not what I want. I need to specifically move it somewhere, so I'm going to go point to point. So I want that point to be right there. That's no different than snapping to a corner. But my problem is I know where it's at, but that's not the final resting place. So now I'll make a free move, and now I grab this. Watch that over there. There's 1. Hit enter. There it is. So now that's how you precisely move something and position it. Okay, what else do I need? Well, I need more than one of those. So why don't we do this? Why don't we select it when I hit M? Make sure you hit Create Copy. Now, that one's positioned. It just needs to move down this way. And I needed to move it about 6 inches. That looks pretty good. Now I've got 2. Okay. Let's do it again. Hit Move. Make sure Copy's selected. This needs to be a point-to-point move because I need that corner right there. And then I need to move it in an inch. So we'll get this out of the way a little bit. Now watch your signs here. You see how it says -1? Okay, so you have to watch which direction you're moving it. All right, so that looks pretty good. Now, I need a dado for the bottom. I don't know all the dimensions on it. Actually, I do, but a lot of times you don't. Well, I do know it's 0.75 because that's the thickness of the material, and it can't be wider than 23, so that's where we'll start. And we'll hit the move command again. It's a point-to-point move, so that goes there. And then we'll move it over about an inch. That looks like it to me. Okay, so there's that. Now, funny part about this is you don't have to I don't have to worry about this. So if I put 28 inches, it'd be fine. It doesn't matter. All right, now the next thing I need to do is to actually put the back in. So, well, let's see what the dimensions are. If I want to measure something, how far is it, for instance, to right here to right there? 29 3/4. Okay. So I think what I'll do is, I think I'll do this. I think I'll create this. All right. So 29.75 by 0.75. That should be the right size. Once again, we'll select it. Hit move. It's going to be a point-to-point move. We'll move that to there. Looks good to me. Okay, now that's all selected. I'm going to finish the sketch. Okay, so that's finished. All right, now we're going to hit Q. Okay, we're going to select that and that. Let's move this over to make sure everything's selected. Now you see how the part that got hung over didn't get selected. Hit that and that and that. And then we use our arrow and set our dimension minus 0.25. And there's our dados. So that's how you create that part with the dados. Now we've got one more little operation that we need to do. The last thing we really need now are adjustable shelf holes. Well, where do they go? Well, this is going to be a door right here, so I probably want to center that way. So let's do this. Let's put that on a sketch. So let's create a sketch, and let's pick that surface again, all right? All right, so what do we know? Well, we know first there it's a 5mm hole, so let's draw that. And I just type in 5 and mm, and that converts it for me, so that's 5mm. Okay, and I can actually turn that on and off. That makes it easier. And here's what we're going to do. We're going to select this. We're going to go to Create Rectangular Pattern. Now we can do all this in one step, but it's easier if you do it this way. Okay, select the direction. I want this way. Okay, I want to go minus 12, and I want 2 holes. Okay, and that looks pretty good, and I hit OK. So there's my 2 holes, all right? So that's the first step. Now let's select those. Like I say, you can do this in one step, but it's easier to do it if you break it apart like this. Okay, let's get our direction. This time it's going to go up and down. Okay, the spacing is going to be 32mm. Okay, and I need 5 holes. Okay, now on your spacing, make sure that's spacing. Yep, that's correct. All right, we hit OK. So there's our holes, all right? So there's our adjustable shelf holes, but our problem is we have to figure out where to put them. Well, once again, I know where I pretty much want them. I'm going to show you another concept. If I click construction, what I draw is different. So I'm going to snap to right there and draw a line straight down. Okay, and I'm going to come up here. Okay, there is the midpoint of that line, and I'll just go and hit that. Okay. Now what I know is I want that hole 2 inches from there. So what I'll do is I'll select this, hit move like we did before. It's a point-to-point move. Pick that hole, pick that dot. Okay, we're not done. Move it over. Use the slide. I'm looking for -2. Sometimes it snaps in there. Perfect. Hit OK. All right, now those are positioned, and I really don't have to get rid of those construction lines because that's actually for alignment, and it's on the sketch. It gets turned off. I'm going to hit Finish Sketch, come over here. Now what we need to do now is turn those into 3D, so let's zoom in on them. And -0.5. Okay, now let's just go down the line here and pick them. And you can see them. I can tell you sometimes you pick the wrong thing, and if you do, just unpick it. Okay, we'll come down here. We'll do the same thing. We see our holes get drilled. And we hit OK. How about that? And there's our part. So now we've totally created our cabinet part. That's our right-end panel. We've actually created a solid model of it. Now at this point, this is a body. If I were going to turn this into a cabinet, and this would be one part, then I would convert that to be into a component, and then a component then can be combined with other components into an assembly. So once again, all we're trying to do is make a cabinet part. We're trying to keep it really, really simple. Now that our part has been created in the design workspace, the actual toolpathing functions are performed in the manufacturing workspace. The first step is to figure out where the part is going to fit in the stock. That's done in a process called setup. Let's take a look. Okay, we've got our part modeled. Everything's fine. Now, let's talk about how we make it. So let's go to Manufacture. And the first thing we're going to have to do is setup. Setup means how the model's in the material, how that's on the machine. So let's go to File, New Setup. This is what comes up by default. So what you see is this transparent stuff is the material. At this point, this is really important, and that is the orientation of the axis. Now you see how Z's up, Y is this way, X is this way. That corresponds to your machine. So if you're standing in front of the machine, that's what the axis directions are. Now, why did this work out automatically? Well, because when I created that very first sketch and I determined the work plane, I picked that horizontal plane because I knew that corresponded to the machine itself. That's not always the case. Sometimes you get this part and it's sitting up on end. What if it's part of an assembly of a cabinet or something? And you may not be able to rotate it because it interferes with the cabinet assembly. So in that case, what you have over here is the ability to actually change the orientation of that. All right, so you can make that line up. All right, the other thing is you can, sometimes you've just drawn it wrong, and to me it makes more sense to actually get it in the correct plane before you do the setup. But either way, but that's what that is, so that has to match your machine. Okay, so let's assume that does. Now, let's figure out what we're gonna make this out of. So our stock, let's say our stock, I've got a fixed size. I went out in the shop and I found a piece of material and the width of it is 23.5 and the depth's 35 and it's 3/4 thick, 0.75. Okay, let's take a look at that from the top and see what we've got here. So if you look at that, you see how it's, there it is. And you see how it's centered. Well, that might not be the case. It might not be centered. So for instance, it might be from X minus, let's say we're coming in an 1/8 of an inch, 0.125. All right, and watch it'll shift. And the same thing down here at the bottom, we may say, okay, from Y minus, I'll come up 1/8 of an inch, 0.125. All right, and we can kind of see what happens there. And so that's what that looks like. And so that way that might be, say, okay, I'm going to leave 1/8 of an inch on each side to cut off the factory edge. And a lot of times this isn't a perfect rectangular piece. And the height or thickness of the material, we don't care because the material is the same thickness. Okay, so I'm pretty happy with that. Now let's go back to, in fact, let's just close that, all right? So we got that figured out. Now, but I need to change something. You see where the origin is? That's not going to work. I want the origin down here. So right click, edit, let's get you back in here. Now go back to setup, all right? So what I want to do is for stock point, I want to say pick that box point, click that little corner down there, and that's where the origin's going to be. So that's what makes it fit on the machine. So that's where the XY origin is. That's also where Z0 is. Now, if for instance I wanted to touch off to the top of the material, I would touch that. And see, so now, so the origin's the corner of the material, and Z0 is the top of the material. In our case, we probably want it down here. All right, so we hit that, and we'll zoom back out. And now everything's set up so that now when our tool paths are actually created, everything will line up with the machine. Before we start creating tool paths, let's take a look at the tool library in Fusion 360. It makes sense to create this ahead of time because it makes you more efficient and leaves less chance for error. This is how mine is set up. To access the tool library, click here, and you'll notice there's lots and lots and lots and lots of tools, and a lot of them have nothing to do with what we do material-wise. So I would recommend that you do what I've done. Let's start out here. Let's bring this over. First off, let's turn all that stuff off. Okay, now what I've basically done is created some actual local libraries. So here's one for the 23, here's one for the IS, here's one for the Pro. You know, take a little bit of time and do that, and then it's much simpler to actually select the tool that you're going to use. Now here's an example. Here's the ShopSabre Pro. Tool 1, 2, 3, 4. Let's double click that. And then that brings up everything about the tool. So let's start over at General. There's where the description is. So I've written out 3/8 compression. You could also put the vendor and the product ID and a link to it if you wanted to. Okay, this defines it. It's a flat end mill, which is a router bit. It's inches, 2 flutes, clockwise. It's carbide and there's no coolant. And then this is where you plug the numbers in. So the diameter is actually 374. Okay, the shaft part doesn't make any difference to us in this. Now tool holders, you can use them or you don't have to. Now the reason they're used in metalworking is because sometimes you have complicated setups and they're worried about collision. So by including the tool holder, they can determine if it's going to hit something. Once again, we don't really need that for routing. Feeds and speeds are interesting. This is a really important part. There's your spindle RPMs. There's your feed per tooth, which is chip load. There's your feed rate, lead-in feed rates, and so forth. Now, there's a thing here you may not be familiar with, that surface feed. That's used in metalwork, and it's not so popular in woodworking. It basically defines how fast the tip of the tool is going through the material. Just think about this. The smaller the tool, the faster you spin it so that it goes through the material at the same speed. There's actually a formula to calculate that. Once again, that's not popular in woodworking. Pretty much you're going to get the RPMs and you're going to get a chip load, and the rest is calculated. And then finally, this tab that says post processor, that's where it goes in the machine. So when I say number 4, that tool goes in the tool slot floor in ATC. Now we're ready to start actually creating our toolpaths, and we'll do that in the order that things will occur. First, we drill holes, then machine the dados, and finally cut the part out. Okay, let's start by selecting drill. And it brings this screen up here, and you'll see a lot of different stuff here, and we have to fill this out. Let's select our tool. So our tool is going to be, there it is right there. And it's all the feeds and stuff are already filled out, so we don't have to mess with the rest of that. All right, this next one is geometry. So what do we want to do? Well, we want to drill those holes. How are we going to select them? Well, we've got the models there, so we can just pick this insides of the holes. So that's what that is, select faces, and here's what that does. You notice it joins them together. All right, perfect. All right. Now let's go on down here. Now, this screen right here has to do, and let's look from the front, at different planes, retract planes, how deep holes are, and things like that. Let's take a look at what do I really need to know here. I need to know the bottom height. So where's the bottom of the hole? Well, let's look at that. Right now I've got it set at hole bottom. What if I set that at stock bottom? Watch the holes. See how they get longer? So I'm reading the depth of the hole off the model. Well, what I want is hole bottom. Once again, you can actually just plug the numbers in if you want to, but it makes sense if you've got a model, just take the data off the model. Okay, so that came out pretty good. Now, let's back up again. Let's see if there's anything else we need to think about. Okay, that's covered. Okay, now this actually is a cycle type, and there's lots and lots of different cycles. All we want to do is drill a hole. Right? So that takes care basically of how we do our drilling. Now let's look at what the simulation looks like. All right, so let's set up simulation. We'll click this. Now, generally what I do is our mode, we're going to show our stock. That's what this does. I want the stock to be transparent. Now, over in colorization, I've had better luck with material and selecting ceramic as a material. It just looks better. That doesn't mean you have to. Okay, so when we do this, here's what happens. We have this little player here. Now, that's what's going to happen. So right now, that's showing us a simulation of what's going to happen when we run that toolpath. So we've created the drill toolpath and we've simulated it, and we're happy with it now. Okay, now let's do our pocketing. So we'll go over here to 2D, pocket, and it brings this panel up here. The first thing it says, what tool am I using? Well, I've already set that up. So if I just go over here, tool library, I want that 1/4 inch. I'm using a 1/4 inch because I want those inside corners to be smaller where my joints fit together. So I hit that. Okay, so and that's all filled out because that came from a tool library. Okay, then this basically is select the geometry I want to use. All right, well, nothing's selected. So if I go right there, that picks the bottom of that. Remember, you've got a solid model here, so you can just pick the bottom of it. There's lots of ways to do this. You could actually put real numbers in, but to me it makes the most sense to do that. And you'll also see there's other things that you can add. And remember, a lot of these operations have to do with metalwork and not necessarily with what we do in wood or plastic or aluminum. So sometimes there's a lot of stuff in Fusion 360 that we really don't need. And that's one of the reasons I wanted to do this lesson, was try to get it down to something more manageable. Okay, let's go here. Now this is extra heights. And once again, we looked before. That shows you an explanation of what each one of those are. Right now, the main thing I'm interested in, how deep am I going to cut? So it says bottom height, selected contour. So that should be fine. I really don't have to do anything else. Okay, let's go over to passes. Now, there's a couple of things here. Sideways, this is where you determine climb cut or conventional cut right here. Okay, finishing pass is all, maximum step over is the step over in the pocket, so that's probably fine. Stock to leave, I'm not going to leave any stock, so I just turn that off. So when you see something, like if you do multiple depths, that's what turns that on. If you don't do multiple depths, you just unclick it. So it actually works out pretty good. And then this last one has, it's complicated too, but it has the lead ends. So let's take a look at it. Let's get in here. I want to do an entry lead in, and a horizontal, it shows you, it basically shows you what these are. It doesn't make a lot of difference in pocketing. It'll be pretty much right. But now on this ramp type, I want you to look at that. We're using this helix. And if you look at the helix, okay, now it actually shows you the angle determines how steep the helix is. Well, you don't need it that steep in wood, so let's just go 30 degrees. And let's see, let's go ahead, let's get this turned down. Let's see what we got. So there's our tool paths, you can see right there. It's kind of interesting since I grouped all this together, you might not want to do that. Okay, here's this helix right here. So what happens, it makes a helix into the material and makes a cut. So that's a really nice lead in. Now let's say that maybe that was too steep. Let's edit this, open it back up. Let's go back over where it said helix, and let's change that helix to 20 degrees. You should be able to see the difference. Okay, and then we'll come back over here. We'll have to close that so we can hit OK. And now, you see that now all of a sudden that's much better. So what that's going to do, that's going to let the cutter cut its way in, so it's a really nice lead in. So that works fine. All right, now let's go back. Let's look at the simulation. Let's play it. And that takes care of our pocketing. Okay, we've got one more tool path, and that's for the outside of the part. And let's try to do this one like we would have in VCarve Pro or even Mosaic, where the cutter ramps in. So how do we start that? Well, first off, we go up here to 2D, and 2D contour would be the tool path. All right, so let's get this out of the way. All right, and so the first thing I want to do is select the tool. And once again, that goes to the tool library. I've already set mine up, so I just select the tool and everything's calculated, all right? And then I need to know where the geometry is, and I'm gonna pick that. And there's actually one more thing, what would be the depth of cut? So let's say the bottom would be the selected contour, so that's fine. All right, so there's my tool path right there. And if I did nothing else, that would actually cut out. So let's go to simulation. Now just remember, when you do simulation, there's a number of different settings. I happen to like these, that doesn't mean you should. Okay, so on the tool, I don't have to show the tool. I prefer to. If I turn that off, you don't even see it, but I still like to show it. And you can show the shaft or just the flutes, or you can show the holder. Once again, to me, the holder's in the way, the shaft's fine. And I can also make it transparent, so that's probably the best way to go. All right, so that's pretty much how I've got that done. I want to show the tool path. The stock's interesting. You don't have to show it at all. But I think when you're doing simulation, having a stock's important. And I use standard mode, the colorizations for the material, and I select the material that's called ceramic. And I like it. Now, sometimes I'll actually run it transparent, but I think when you're trying to look at the geometry that you're creating, having it solid is probably better. And then I hit the play button and let's see what happens. That's what's going to happen right now. If I run that tool path on the machine, I'm going to get that part. The next thing I want to do is, what if I needed to leave an onion skin? How would I do that? Well, let's go over here, edit, right click, and let's go over here to the heights, and then down here where it said selected contours, I'm going to add 0.03, that'd be 30 thousandths. Okay, we won't do anything else, and we'll hit simulation, and we'll see what happens. We'll see it come around here, and you see there's some material that's leaving. So it's leaving a little ledge there, so that would be an onion skin. So that's how you add that onion skin. You basically add it to that. All right, we'll close this. Now what if, the opposite of that, I want to make sure it cuts through, so I would typically go through and say, okay, instead of adding 30 thousandths, I want to subtract minus 0.005, 5 thousandths, like we do when we're doing nesting. Okay, we'll go back, simulate it. And now it cut all the way through. Okay, perfect. The next thing I want to do is move the start point. So how do you do that? All right, let's go back to our toolpath. Go to edit. The start point's out on this linking tab down here where it says entry position. So let's pick that. Let's say I want it right there. All right, now watch what happens. You see it moves. We run our simulation. Simulation is really your friend in Fusion 360 because it's so good. It creates the actual part, and you can do like I'm doing here. Just do one thing at a time and see what happens, and that makes it much simpler. Okay, that's pretty good. All right, now what else do I want to do? Well, probably normally I would have an overlap. So the cutter comes around and overlaps a little bit, and then it exits. And I do that so there's not a bump there. So let's try that. Edit. And I believe that's in this layer here under passes where it says finishing overlap. All right, so let's say 0.5. We'll hit OK, and you see there it is. Let's run our simulation. Okay, so there's where it started. Okay, that's pretty good. Now, there's something I want to show you. Okay, you see all these little lines in here and these arcs? Okay, that's put in there. Those are things that are used in metal mills, lead-ins and lead-outs. Remember, they have to be much more conservative on leads and stuff because the material's so hard. Well, I'd rather get all that out of there. So here's what I'm going to do first. I'm going to zero all that out. Now here's how you do it. Okay, we'll go over here, we'll right-click. All right, so let's go down here. Okay, there's leads and transitions. And let's see, I'm going to unclick that, and I'm just going to zero all this out. 0, 0, 0. When in doubt, zero it out. And then start from there and do one thing at a time. All right, now let's see what happens. Now, if you look at that, those are all gone. Okay, so now that's better. Okay, now, what do we want to do next? Well, why don't we add a ramp next? Well, how do we do that? Well, we edit the toolpath. And we come over here to the outside, and there's a thing that says ramp, okay? And what do I want? Let's close this down a little bit. Let's make it about 30 degrees, will be about the right slope. The rest of it, I don't care. And we'll hit OK, and there's our ramp. We'll hit our simulation, and we'll zoom that out so you can see it. Tool ramps in. Should be coming on around here. Okay, perfect. Now there's another thing I need to add though, and that has to do with the lead out. See, because what happens is, if I look at that from the top, you see that tool doesn't leave the line. So if it stops there and then raises, I'm probably going to get a mark. So let's do this. We need to change something. So let's right click. All right, now what we're going to do is we're going to, let's see here, horizontal lead out, sweep angle. Let's go about 5 degrees. And let's in fact, let's just see what that does. It may not, I may need more information, but let's see what that does. Okay, I don't see anything. I need another dimension. So if I look above it, it didn't sweep out. I defined something, but it didn't solve it. So let's add one more thing. So let's go to edit. And we'll go back over here and lead out, linear lead out. Let's go point 1. Okay, we'll hit that. And there we go. Okay, if we look at it from up above, you can see what I mean. Okay, now see what happens? So this is the overlap. It completes, then it starts out. What that does, that makes that slowly move away, and you shouldn't have a mark there, so it should give you a really, really nice exit. So that's what we're trying to do. So that looks pretty darn good. Let's run our simulation. And there's our toolpath. You know, another thing we want to look at is the direction of cut. So here's where that's set. So right click, edit. Okay, if you go to this tab right here, sideways compensation, so left is a climb cut, right is a conventional cut. All right, now watch it. Now, by doing that, we run the simulation, you see it reverse directions. So you might want to do that sometime. So that's how that's done. So once again, you see what happened. We'll close that. Now that we've created the toolpaths we need, there is a way to save those as templates in Fusion 360 and then apply them to other parts. Let's take a look at how that's done. Okay, let's do a little housekeeping. Let's rename this. Let's call this right end. Okay, let's call this, that's a drill. Let's call this a 5mm drill. Let's call this let's call it a dado. So P25 or 1/4 inch bit dado. And let's call this one a P375 compression. Now let's select right end and let's do a simulation. And we'll move this over a little bit. And we'll hit play. There's our holes. There's our dados. Okay. That just about finishes that. Then we pick up our stretcher dados on the front. And finally we cut everything out. That came out perfect. Now let's pick our 3 toolpaths. Let's right click, store as template, and let's call this Fusion 360 lesson. And now we've got those stored. Okay, now let's see how we would actually apply that toolpath template to a new part. So let's do this. Let's go over here, File, New Design. And I'm going to save that design. I'm going to call it Router Bob 1. Okay, so that's saved. Now I'm going to open the data panel. Okay, I'm going to right click here and say Insert into Current Drawing. So it's going to insert that in there automatically. And you notice when I get in here, it's the Move Copy function is set up here so I can position, but it turns out it's positioned correctly. So now there's my part. All right, let's go to Manufacture, and you see there's nothing there. All right, so what do? Well, we create a setup, just like before, new setup. All right, what do we know here? Well, we probably know that our stock is a fixed size, so let's say, once again, let's say it's 23.5, and by 35, it's 3/4 thick, 0.75. Okay, and let's come back to the setup. This is correct, so what we need to do is tell it where we want the origin to be. It's going to be right there. Okay, so that's set up. So now we've got that set up. So what did we do? Well, we said, okay, this is the piece of material that we're going to make it out of. This is where the part is positioned in the material, and this is what locates where it goes on the machine. Okay, now watch this. We come back over here, I right-click, Create from Template. There's a Fusion 360 lesson. That's what I named the template. And then when I expand this out, you see there's those toolpaths. But now I have to it doesn't know where to apply them. So I'll just double click this. That's the drill. And so it's just going to pick the drills. Whoops. If I click it correctly, well. Okay. All right, so we've got our toolpath for the drill. Now let's do this. Let's do the dado. Okay, now that one's going to be trickier. There it is. And here, see the bottoms of those dados. Hit OK. There's a toolpath for that. And then let's do the compression, and that would be on the outside. Sometimes also on the compression, if you want to change the start point, you may have to do that. Let's see where. So to do that, I would just say put the start point right there. Okay, and there's our toolpath. So now let's go up here, and let's go to simulation, and we'll get that out of the way, and we'll play it, and that's all it takes to toolpath the next part. So toolpath templates are really powerful. You can see it's cleaning that out. And then we'll get those stretcher dados on the front, and finally the outside. So that's how you apply a toolpath template. Now that the toolpathing is finished, it's time to create the code files that the ShopSabre machine control requires. G-code is a programming language that most CNC machine tools use. Think of it this way: Fusion 360 has created a machining model of what we're trying to make. Then a post-processor converts the model into the code files that we need. The first part of this section will deal with downloading and installing the post-processor. So far in this lesson, I've used Fusion 360 running on the Mac side, but I've switched over to Windows now because we're going to set the post-processor up in it, and that gets in the Windows file structure, so it's probably better to do that. So, okay, so how do we get the file that we just created? Well, because those files are saved in the cloud, I can come over here, click that. There's the file routerbob1. I'll double click, and we'll close that, and there's the file. And there's your toolpath, so everything's ready there. Now, there's one thing that, let's do a little housekeeping right here. Okay, what opens up your G-code is determined here in a preference. Let me show you where that is, just in case it didn't set it up correctly. If you go down to Manufacturer right here, it says see Windows Notepad. That means that the G-code file is going to be opened by default to Notepad. You might want to check that in case that wasn't installed automatically. Okay, now let's go to this icon, and this brings us into the post-processor panel. All right, so let's assume you don't have a post-processor at this stage, all right? So, well, where do you get one? Well, you could call ShopSabre, but it's a lot easier to just do this. All right, go to Search for Post in our Autodesk HSM Post Library. So click that. That goes out on the internet. And you get to this screen and just type in ShopSabre. There should be two posts in there right now. There's a plasma post and the WinCNC post. So there's that one. Okay, that's what it looks like. Now that doesn't mean anything to you, but here's what you need to do: download it. And then this will save you a lot of time. Show where it is downloaded. It's in your download folder. Right click it and copy it. Okay, so now it's on the clipboard on my computer. We just turn this off. Okay, now this is where it actually, you want it saved on your computer, and this is where it's saved. There's a path to it. So I'm going to click on that, and I'm just going to right click and say paste. And it's going to paste it into that folder location, and I'm going to tell it that's fine. I already had a copy in there. So you won't have that problem. Okay, so it's there, and then over here, this is where I select them. And there it is right there. So basically, that's the post processor. All right, now let's look at some other things that are on here, okay? You can open configuration, but you probably don't want to mess with that. If you have a problem, what we try to do is we try to have Autodesk have the most current, most up-to-date post possible. So when you download it, just like I did, it's the latest, greatest. So that's what you need to do. And they've been unbelievably helpful in making sure everything was up to date. If we asked for a change, they did it. So, all right, let's go back over here and let's look at the screen again. Okay, what else we need? Well, now, all right, in case it's not set up that way, the extension file should be .tap. That's short for tape. About 50 years ago, they used punch tape for CNC machines. Actually, they were called NC back then. And so TAP was the extension for that, so it's been around a long time. Okay, this is the output folder right here. And so this is where programs are going to be saved. So you may want to change that. All right, now down here, program number or name. You really don't have to put that in there. Some machine controls require that number. We really don't. You can put a comment if you want to put one there. Personally, I like to keep the files as clean as possible. I don't like a lot of stuff in there. Now, here's something that's really, really, really important, and it's these questions here. Okay, write the machine, yes. Write the tool list, no. Okay, sequence number, increment 1. Sequence, so what happens, each line is 1, then 10, 20, so forth. Use sequence numbers, no. All right, now the reason I say use sequence, it just makes the file bigger. Sequence numbers like that were used when we wrote code by hand 40 years ago. It's not that way now. Rotary axis table, no. Separate words with space, yes, it's easier to read the programs. Use coolant, no. Use tapping cycles, no. What else we got? Use tool changer, yes. If your machine doesn't have a tool changer, the answer is no. It's really important. That's how you configure that. That's all written into the post, and you're just turning things on and off. So it's really important. If you've got a 23 without a tool changer, that needs to be no. If you've got an ATC, it needs to be yes. And I think that's pretty much everything else is fine. All right, now then the other thing is open NC files in editor, and I'll show you what that does. So let's hit post. All right, so we'll just overwrite that. Okay, so that's the G code. So that's the G code file. Okay, let's go back and let's change something. Once you get it set up, it's simple. Let's say, okay, I'm going to call this one Router Bob 1. All right, I hit post. Router Bob, see I picked that up, Router Bob 1. There it is. So at the top it says Router Bob 1. Now, when the machine control sees these things in these brackets, it ignores them. It knows it's a comment. So that's the program that your machine uses to create that file. It's really simple once you get that set up, but I wanted to go through the process of setting up the post processor because people have trouble with that. You know, where do you get it? Where do you put it? So that's how that should be set up. I hope you enjoyed this lesson. Fusion 360 is an unbelievably powerful program for designing the products that you might make with your ShopSabre CNC router. Because of its power, getting started can be a little intimidating. I wanted to create this lesson to help you get started. Hey, thanks for being part of Sabre Nation University. I'm Router Bob.